All right, so that's 4.2 here, basic probability rules. Again, I think these are rules that you should have known or learned back in middle school, 8th grade, freshman year Algebra 1, possibly. So again, I think you're very familiar with these rules. Okay, so first we're going to talk about what a probability model is. So this is like a little bit more highfalutin for a stats class, right? So probability model, it's a description of a chance process, and it consists of two parts. So first of all, you have to list out all the possible outcomes. So when you list out all the possible outcomes, that is called the sample space. You're trying to identify the sample space. And then the second thing is you should list out the probability of each outcome. Now, most of the time when we look at this chance process, they will be equally likely. So we only have to really list out one, okay, because these outcomes will be equally likely to occur. So for instance, we are rolling a pair of dice. So here are all the different options when you roll a pair of dice. You can get a 1 and a 1, a 2 and a 1. Now notice here, like this situation, a 2 on the red die and a 1 on the blue die is different than a 1 on the red die and a 2 on the blue die. So although, like, you know, it's still a 1 and a 2, it's a different situation. And again, if you look at this, each of these outcomes has a 1 out of, and the total is 36. So the probability here would equal 1 out of 36. And again, it's because each of these 36 events is equally likely to occur. If you were going to list this in the sample space, so say, let's use SS for sample space. When you do that, you use braces. You could put the numbers in parentheses like this. So say like this 1 and a 1, say that was a 1, 1, right? And then the next one was a, let's go down, was a 2, 1. Okay, so you can list them like that if there's a pair of objects. I had one more thing to mention. Sample space, rolling dice. Oh, if you want to figure out how many total possible outcomes there are, you can use this idea called the fundamental accounting principle. It's going to be talked about in 4.7, but you know it. So if you're going to roll 2 dice, right, there's 2 spots. And this is a multiplication symbol. How many numbers could the first die be? Well, it could be 1 through 6. That's 6. How many numbers could the second die be? 1 through 6. That's 6. And 6 times 6 is 36. And that's the total number of outcomes. So sometimes it's hard to think, oh, did I include every item in the sample space? So it's good to know how many you're looking for. So when you talk about probability, we're looking for the probability of an event to occur. And an event is just some outcome in the chance process. So when we are looking at equally likely outcomes, again, the probability of an event is just the number of times that event can occur out of the total number of outcomes. And again, this is how you typically have found probability in the past. Okay, so let's take a look at the next slide here. Okay, question. So example 1, when you get a head, suppose you flip a fair coin 3 times. Give a probability model for this chance process. Okay, so there are 2 parts, right? So the first part of a probability model, oops, sorry about that. The first part is the sample space. Okay, so the sample space. So I'm just going to list out the letters. So it's good to go systematic. But again, if I'm tossing 3 coins, that's 3 coins. There are 2 sides to each coin. 2 times 2 times 2 is 8. There will be 8 total possibilities. So we'll go heads, heads, heads. And then let's just change the last one to a tails. Heads, heads, tails. Now let's flip-flop. Let's leave the first one as a heads. Let's change the middle one to a tails and put the last one back to a heads. And then let's go heads and then tails and tails. Those should be the 4 outcomes where heads is first. And now we'll go to the tails. So we'll do tails, tails, tails. And I'll do the same thing I did here. Let's do tails, tails, heads. And then we'll switch the second and third. And then we'll make the second 2 both heads. And to me, that's a systematic approach to listing out the sample space. Okay, and now the second part is the probability. So what is going to be the probability? Well, there is a 1 out of 8 chance that each of these events occur. So your probability is 1 out of 8. And again, it is because these are equally likely events. You could also have the decimal right. So if my calculator serves me correct, I believe it's like 0.125. So 1 divided by 8 does come out to be 0.125. So you could also have 0.125. Okay, now it says define event A as exactly getting 2 heads, exactly 2 heads. So find the probability of A. Well, I'm going to change this to red because up in my sample space, I'm going to circle or box all of the events that give me exactly 2 heads. I am not going to circle the first one because that's 3 heads. I don't want that. I want 2 heads. I want 2 heads. I want exactly 2 heads. So in this sample space, to find the probability of A in this problem, I have 3 outcomes that match my event out of a total of 8. And again, that could be your probability, or we could get the decimal, which is 0.375. And there's your probability. Okay, just some basic probability there. Okay, next objective is coming.